equals 55 meters per second. It accelerates at 2.2 meters per second squared until the engine stops at 150 meters above ground. A was the maximum height the rocket reaches. So, well, first we just want to find out what the initial velocity is up at that 150 meter point. And go ahead.
That's 55.
Well, no, the velocity of V0 55, that's the V0 at the ground when it takes off. But we want to find what the velocity is where it stops up there.
All right.
And then we use that for the V0 to time it to go up and stop, just like we did with the last problem. So first we want to find out V squared equals V0 squared plus 2AY. And so 55 is meters per second is V0. So acceleration is 2.2. And then 150 meters. And so it turns out to give us a V of 61 meters per second. So then we just time that. We say, well, T then is equal to V minus V0 y components, right, over minus G. And this is 0 at the top. So it's just 61 meters per second over 9.8 meters per second squared, so it's about 6.2 seconds. So that's how long it takes it to go up and stop. So then knowing the initial velocity and the time from the 150 meters up to the top, we can solve for that distance. And we just add that to 150 meters. So it's going to be y equals v naught y times t plus 1/2, well, it's actually plus 1/2 at squared, but we'll just go ahead and put the g in for a and then plug in the numbers. So we get 61 meters per second times 6.2 seconds minus 4.9 meters per second squared, and then 6.2 seconds squared. So it adds up to about 190 meters. So then we add that to 150. So y total then is just going to be 340. So that's how the maximum distance, vertical distance. Well, anything on that part?
So you got the velocity from that first part, and then you used it to calculate the initial velocity.
Well, this is the velocity at 150 meters.
Okay, so that is the initial velocity after.
Right after, for the segment after that. For this segment over here, we're calculating how far it is from there up to the top.
And was it number 2 again? The equation used the second time?
You mean this one?
Yeah.
This one's number 2, yes.
Yeah.
Right. This one here is number 3, right? And this was number 4. This is supposed to be a capital Y. Just meaning that we added the 2 vertical distances.
Why is v sub y 0?
V sub y.
You just crossed it out. T equals v sub y minus v naught y. Right there.
Oh, this is because it's that's because it stops at the top.
Okay,
So
so
the component velocities. Well, anything else on that one?
Okay, so the maximum height was the 340, right?
Yes.
Okay, so how many significant figures do you want us to do for these two?
Well, I'm not too much of a stickler about it because I know you're just starting. But we try to, if we're thinking about it, round them off to 2.
Okay.
That's the reason we give G as 9.8 instead of 9.81. But this turned out to be exactly 340. It's not that I rounded it off to 2 sig figs. Well.